So we're going to continue on with our approach of looking at regression models. So what do I mean by regression models? I mean that these are the cases where we want to fit a trend line to the data. So just some examples of options where we might want to use a trend line to describe what's happening. Many of the examples I've put up here are examples where we can see we're looking at change through time. Of course, this doesn't have to be the case that we're looking at changes through time. It could be a wide range of scenarios that we look at. But one of the most common examples is where we're trying to describe something that happens through time rather than comparing two different time periods. So the general approach that we use for this kind of analysis is that we fit a trend line to the data. We use the equation of a line as our base case for describing the changes through time. And rather than fitting a straight line to curvy data, what we do is we use the log transformation to try and make the data look approximately linear. Okay, so this is not perfect, and remember that this is just first year, so we're getting the basics down. But my experience in real life is that if you know these simple transformations, you can actually address a wide variety of research problems. Quick reminder, getting it burned into everyone's mind. Okay, yes, we know the equation of a line. In regression analysis, we use some specific terms to describe things. So the intercept and the slope are the same, but the thing that we place on the vertical axis, the y value, we call that the dependent variable or the response variable, and the x variable, the thing that is being plotted on the horizontal axis, is usually called either an explanatory variable, which tends to be the language that I use most often, or some people call it a covariate, or there can be some other words. But you can see that the important thing here is that we have just the equation of a line, and the x and the y, we just have some specific values to work with. The decision rule that we use to fit the equation of a line, there are many possible lines and many possible decision rules we could apply. The one that we use is to fit the line that minimizes the sum of the squared error terms. So that's how we can wiggle the line around the data and ultimately settle on one where the squared error terms will be the smallest possible values they can be. Why are we squaring them? Remember, because the positives and the negatives would cancel out. So here I've taken, this is what it looks like when we're plotting a trend line. My values are centered around 0. So you can see here that the positives and negatives add out. This is a plot of my errors rather than my actual values. So you can see with the wingspan example, it would be something like this. I have yi, which is my actual measurement. I have my fitted value, which is my predicted y value, given a specific value of x. For each fitted value or predicted value, there's an error. On average, those errors sum to 0. There'll be positives and negatives. The decision rule we apply is we square those error terms, and we're looking for the line that will minimize the sum of the squared error terms. What is the process that we use for progressing through this? So we use some scatter plots. So in ANOVA analysis, we focus on a box plot. In regression analysis, we focus on the scatter plot. Very simple to implement. We just have y tilde x. Okay, so we've not got a comma here for x comma y. We've got y tilde x, which is the same way that we're setting up our linear model. Okay, so we're writing our plot format, y, length on the vertical, age, x on the horizontal. What do we do after we have plotted our data and decided which transformation, if any, we want to use? We then estimate our linear model. So it is exactly the same format that the plot takes, except that what you're going to do is you're going to, instead of have the plot function, you're going to have the lm function. And so then we save that. So you can see here I've saved the output of my linear model in the object lm.bird. You could call it lm.1, lm. whatever, something that kind of makes sense to you. So here it's modeling wingspan over the age of the bird, so I've called it lm.bird. Now, just another important recap, if we're applying these transformations to the data, we need to be careful about how we interpret the slope. So our 4 options here, just a recap of what we do. If we have no change in the x or the y, the interpretation of the beta or the slope coefficient is easy. If we have a transformation of the y, then we have this beta times 100% change in y, so we have this percentage change. If we then apply the log transformation to the x-axis, we have this beta divided by 100, so 1% change in x leads to a beta divided by 100 unit change in y, and the log-log model is a 1% change in x leads to a beta percent change in y. All of these changes, when we put them in the regression context, we qualify by saying on average. So it's a reminder that we're always talking about not a specific case, but what happens on average. When we take many measurements, we're looking at the pattern on average. So what is the process for getting our trend line? We can get from the summary of the regression model that we saved. So I saved it as lmbird. I apply the summary function to this, and it will report a whole bunch of information for me, which we then collate into a table. In terms of adding this information to my plot, I use the AB line function. So I have estimated a linear model with an intercept and a slope. If I apply the AB function, the AB line function, it will read from my lmbird model the intercept and a slope. And I think, as I've mentioned before, the reason that we're doing this is it is automating processes so that we reduce the chance of an error. So I've saved the regression model output and I plot directly from calling the regression model output rather than typing in the equation of a line. I rely on everything being automated, and that minimizes the chance of an error and it makes things nice and reproducible. Final thing for a plot was we looked at adding a legend to the plot. So there are, we describe where we want to place the legend, and then we put the things that we want to describe. So the observation and the trend line, we can describe the colors and the type of line that we've fitted, and we'll look at some more examples of those. So that is a recap of the process, or the technical things, and the next thing we'll do is we'll start to look at some examples.